Bismillahirrahmanirrahim. Assalamu alaikum dear ones. Hope so you all are fine by the grace of Allah Almighty. Students, in our previous lecture we have completed exercise 1D and today's we will solve test paper 1, question number 1, 2, 3, 4 and 5. So let's start. Test paper 1 and question number 1 is rewrite the following using set builder notation. As we have already studied set builder notation in which sets is expressed in the form of a rule. Let's start part number 1, which is A is equal to the set for 8, 12, 16 and so on. We can see that these are the multiples of 4. So in order to write this set in set builder notation, and the solution is in set builder form or notation, set A is equal to the set for whole x such that x is a multiple of 4. Part number 2 is B is equal to the set 2, 3, 5, 7, 11, 13 and 17. As we know that these numbers are prime numbers, so in order to write it in set builder notation, we will write it as B is equal to the set x such that x is a prime number. And we know that prime numbers are the numbers that have only two factors, 1 and themselves. Next, move towards part number 3, which is C is equal to the set 1, 4, 9, 16, 25, 36 and so on. As we know that the natural numbers are 1, 2, 3, 4, 5, 6, 7, 8 and so on. And you can see that these are the squares of natural numbers. So in order to write it in set builder form, we will write it as C is equal to the set for all x such that x is a perfect square and x belongs to natural numbers and represent natural numbers. Part number 4 is T is equal to the set 1, 3, 5, 7, 9, 11 and so on. These are the odd integers, so in set builder notation we can write it as D is equal to the set for all x such that x is an odd integer. Now let's move towards question number 2, that is state whether the following are true or false. Part number 1 is if 3 belongs to A and A is a proper subset of B, then 3 belongs to B. As here is mentioned 3 belongs to A, which means that the digit 3 is present in the set A and also A is a proper subset of B. It shows that the digit 3 is present in the set B. So we can say that 3 belongs to B. This statement is true. Part number 2 is if A is equal to the set empty set and B is equal to the set 0, then A is equal to B. In set A we can see that here is no element and in set B we can see that here is element just 1. So this shows that A is not equals to B. This statement is false. Part number 3 is if A is equal to the set 2, 4, 6 and B is equal to the set 1, 3, 5, then A equivalents B. This symbol, as we have already studied in the previous table, that this symbol represents equivalent. So we can see that in both these sets the number of elements are 3, which means that both of these sets are equivalent. So this statement is true. Part number 4 is if x is equal to the set 1, 2, 3, 5 and 7 and y is equal to the set for all x such that x is a prime number less than 10. As we know that prime number less than 10 are 2, 3, 5 and 7. Then the condition is x is equal to y. So we can see that x is not equal to y as the elements in the set x and the elements of set y are not same and not equal. So this statement is also false. Part number 5 is if A and B are equal sets, then they are also equivalent. Obviously, if two sets are equal, then their number of elements are also equal. This statement is true. Question number 3 is fill in the blanks with member of, does not, a member of, proper subset, does not, proper subset or improper subset, as these symbols are represented with these words. First set is 10, 20, 30 dash and the second set is 1, 2, 3, 4, 5, 6 and so on. So we can see that all the elements of first set is present in the second set. So here first set is a proper subset of second set. Part 2 is 19 dash the set 2, 3, 5, 7, 11 and so on. We can see that 19 is also a member of this set. So we use the symbol member of. Part number 3 is first set is 2, 4, 6, 8 and so on. Dash the second set is 6, 12, 18 and so on. We can see that the first set is improper subset of the second set. As we know that improper subset is that which contains all the elements present in the other subset. Let's move towards the part number 4, which is 27 dash the set 1, 4, 9, 16 and so on. The digit 27 is not belongs to this set. So we use the symbol is not a member of, or we can also say it as does not belongs to. Part number 5 is the set 3, 6, 9, 12 and so on dash. Second set is 1, 3, 5, 7, 9, 11, 13 and so on. In both of these sets, some elements of first set are present in the second set, but not all the elements of first set are present in the second set. So we can say that first set is not a proper subset of second set. Let's move towards the question number 4, that is if A is equal to the set for all x such that x is an odd number less than 10. B is equal to the set for all x such that x is a prime number less than 16. C is equal to the set for all x such that x is a two-digit odd number less than 20. So first of all, from these given sets we have to find. Part number 1 is list the elements of A, B and C. We will make a list of these elements which are already represented in the set builder form. We will write it in the tabular form. So the solution is the elements of set A, B and C are, as we know that x is an odd number less than 10. Odd numbers less than 10 are 1, 3, 5, 7 and 9. Similarly, in set B, prime numbers less than 16. So the prime numbers less than 16 are 2, 3, 5, 7, 11 and 13. And in set C, two-digit odd numbers less than 20. Two-digit odd numbers, as we know that two-digit odd numbers starting from 10. So we have to write odd integers, odd numbers, so that are started from 11, 11, 13, 15, 17 and 19, which are less than 20. Part number 2 is list the elements common to B and C. As we can see that in the set B and C, the common elements are 11 and 13 in both of these sets. So elements common to B and C are 11 and 13. Part number 3 is find the sets which contains the elements of A and C. So we can see that in both of the sets A and C, there is no any common element. In set A, the elements are 1, 3, 5, 7 and 9. In set C, the elements are 11, 13, 15, 17 and 9. Here is no any common element. So we will write empty set because here is no any element which will be present in the set A and C. Let's move towards question number 5, which is express the following in tabular form. As we have already studied that tabular form is that in which all the elements of a set are listed within curly brackets and separated by commas. Set A is equal to set of natural numbers between 2 and 7. B is equal to set of odd numbers less than 10. C is equal to the set X such that X is a color of rainbow. So we have to represent all of these sets in tabular form. As we know that set A is a set of natural numbers between 2 and 7. So in order to represent set A in tabular form, we will write it as the set of natural numbers between 2 and 7 are 3, 4, 5 and 6. Set A is equal to the set 3, 4, 5 and 6 are the natural numbers between 2 and 7. So this representation is called tabular notation. Set B is set of odd numbers less than 10. As we know that set of odd numbers less than 10 are 1, 3, 5, 7 and 9. So we will represent in tabular form such as B is equal to the set 1, 3, 5, 7 and 9. The set C is equal to the set for all x such that x is a color of rainbow. So in order to represent it in our tabular form, we know that the colors of the rainbow are 7, which are violet, indigo, blue, green, yellow, orange and red. This representation is called tabular form, and these are the colors of rainbow. Students, in today's lecture, we have completed question number 1, 2, 3, 4 and 5 of test paper 1. So do practice of these all questions. Stay home, stay blessed. Allah Hafiz.